Hi, hello everyone. Welcome. Thank you for joining me today in my talk, Reason and React with ReasonML. The talk is about the story of ReasonML. We will start by looking at 4 paradigms I've observed in modern web technologies in the recent years. Then we will get to know ReasonML. And in the last part, we will discuss when and why to use it. In other words, we are going to navigate between what I observed in the past regarding web development, what I currently do at my current work, and what I believe the near future of web development will look like. So let's start. Hi, I'm Sara Hillel. I'm a software engineer and a digital nomad. Currently, I'm based on a farm in northern Israel, and the background of the slide actually is my office view. And I work at Walnut, where we build codeless platform for creating sales demo for sales leaders. Previously, I worked as a freelancer for several years. So for most of my career, I worked with early stage startups. As an engineer, especially when building application from scratch, you have to make so many decisions with an enormous impact. So it starts from the very, very beginning with questions such as, how do you even decide on the stack? And to be honest, it's hard. In recent years, it has become even harder. We have so many options to choose from. But how do we decide? How do we know? How do we know what will work for us, what will make our code maintainable, scalable, what will make our work fun, productive? I've noticed that modern web technologies are evolving towards 4 trends. The first one is easy. There is no paradigm shift here. For the browsers, JavaScript is a standard. Always bet on JavaScript seems to be accurate for the near future, whether you like it or not. The second trend, static typing. More than ever before, developers want statically typed systems. In the context of type systems, dynamic means at runtime, while static means at compile time. So the type of a variable is known at a compile time. Some languages require you as the developer to specify the type of each variable. Other languages make use of type inference and the ability of the type system to derive the variable's type. Either way, static typing has a big advantage over dynamic typing, since checks can be done by the compiler and many trivial bugs will be caught way earlier. So great benefit. Next, our third trend, functional programming. To see it in action, I want us to take a look on one tool that has kept shining over the last years, and I'm talking about React. React is a declarative, efficient, and flexible JavaScript library for building user interfaces. And it is popular. When I try to explain its popularity, I think about how it makes me code. And for me, React is like a bit of success, where it's easy to do the right things, but annoying, but not impossible to do the wrong things. Let's try and see it in code. React is component-based. This is a component. This is a component. Everything is made up of components. You build encapsulated components that manage their own state, then compose them to make complex UIs. Components can receive inputs, the props. Props are immutable. You can read them, but you cannot change them. Granting immutability prevents side effects, which makes your code more predictable and simpler to understand and easier to debug. Composing components give you a hierarchy, which facilitates unidirectional data flows. So composition, immutability, unidirectional data flow are all functional techniques that make you reason about your code. And this brings us back to functional programming, our third paradigm. So we've reached our the last one, a concept which attracts many developers and companies. Learn once, write anywhere. Web, mobile, desktop. The canonical examples might be React Native for building iOS and Android apps with the knowledge of React, JavaScript, web developer, and Electron for desktop apps, again, with the knowledge of web development. So these are 4 trends that influence modern web technologies. And what have we got so far? We've got JavaScript with patches. A patch for static typing, a patch for immutability, a patch for functional programming. You find yourself bike shedding with configuration and endlessly adding and learning libraries. Is there any other way to do this? A better one, simpler? Why not just focusing on code? So meet ReasonML. We will jump right into the code, and it looks familiar, right? It is exactly the same React code we've just seen. But now it's written in ReasonML, so it's static type. You might ask, well, where are all the types? And that's a great question. We don't see them here. And that's the beauty of ReasonML. It has a sophisticated type inference system. So what is ReasonML? ReasonML, or Reason, was created by the same guy, Jordan Woki, who created React and React Native at Facebook. It was first appeared at 2016, after the creation of React and React Native. So is it a new language? No, it's not exactly new and not exactly a language. It's a new syntax on top of the established OCaml language that is meant to be familiar to JavaScript developers. So basically, Reason is OCaml with JavaScript syntax. Both Reason and OCaml can be compiled to JavaScript with BuckleScript, a blazing fast compiler. You may be wondering what ML stands for. Clearly not for machine learning, right? Maybe for OCaml, close enough. ML is abbreviation for meta language, which is a functional programming language. It might be known for you from your academic studies, and it might be known for, and you might heard about it from its use of the Hindley-Milner type system, which automatically assigns the types of most expressions without requiring explicit type annotation. Type inference, as we've just seen in the code. Today, there are several languages in the ML family. OCaml is one of them. And by the way, React was originally designed in another ML language from the same family, Standard ML. Okay, so if we say that ReasonML is just OCaml, let's talk about OCaml for a bit. OCaml is a battle-tested functional programming language with more than 20 years of type theory. OCaml is pragmatic. It defaults to immutable in functional code, but allows escape hatches into imperative code when it's needed. For example, you can declare a variable as mutable, but you have to explicitly state I want this to be immutable. So Reason has the exact same AST abstract syntax tree as OCaml. They only differ by the syntax. And both can be compiled to native code, bytecode, or JavaScript. JavaScript directly in the browser with BackerScript. Alternatively, you can use the new REST script, which is a rebranded ReasonML with BackerScript. Okay, so now what you know about ReasonML, let's have a look in some of the language gems that might be unfamiliar for JavaScript developers. One small thing you might see here is the tilde. Let me show you the pointer. Okay, the tilde here. This is for the label argument or name argument, but the main feature in this slide is variant. Variant is a data structure and enables you to choose from a variety of options. In our case, topic can be either front-end, back-end, or data. All are called variant constructors, and the bars separate between them. Let's see. Okay, variant constructors can hold extra data. For example, here, the front-end topic store the language name, a string, and in our case, it will be ReasonML. When you combine pattern matching with variants, you get a powerful combination that lets you execute some code based on the shape of the data. So here, we avoided messy if-elses and got a clean and compiler-verified pattern matching. And so the switch here is for pattern matching, and it's not the switch we know from JavaScript. Okay. What happens if we miss a value? We will have a compile exhaustiveness check, which will save us from these bugs. And it does it in a very expressive way, as you can see. It tells you in which line you were wrong and what branch you missed. In this case is data. One last powerful feature I want to show you is an option. And before that, let's explore the code in this slide. In this code, we use a record. Records are a structure used for storing data in named fields. They are similar to objects or struct in other languages. In order to use a record, you must first declare a type for it. Once you do it, the speaker record can be created and the correct type will be inferred. So it doesn't have to be annotated. Me here is inferred to be from a speaker type, same here for the speaker. Now, what should we do when a speaker has a name, but not necessarily as company? In Reason, there is no null value for any type. Instead, if you need to indicate that a value might or might not be available, you use the option type. The option type is a variant with two constructors. None represent the absence of the value, and some represent the presence of the value and accepts that value as an argument, as you can see here. So here we converted the company to use option, and now we need to handle its usage since it's not a plain string anymore. So this line is not valid. So instead, we use option as a variant, and we can adjust our output to the situation. So here, the first branch will be for a specific company, the second for the general case, and the third where there is no company, none. Okay, so we are close to end, and I'm sure you have more questions than you had before the beginning of this talk. Like, is it ready for production? Do you recommend it? Is it hard to learn? And more. I want to tell you about 2 real-world use cases, and I hope it will address some of the questions, or at least will make you curious enough to explore more on your own. So the first use case is about a common application from a big company we all know, the Messenger app by Facebook. And the second is a startup where I work, Walnut. And we will learn some lessons from both. Let's start with the Messenger app by Facebook. They released some statistics in 2018, 17, 18, after refactoring 50% of the Messenger app through ReasonML. They reviewed parameters regarding quality of code and developer experience, and the numbers are stunning. For example, instead of getting bug reports on a daily basis, they got 10 bugs per year, not per month, not per week, per year. Only in the section which was converted to ReasonML, of course. They also significantly reduced the refactoring time and build time. Another use case is ours at Walnut. I have no references since we started with ReasonML from the very beginning, but I can say we have a great onboarding process where anyone who joins us without any prior knowledge of ReasonML or the code base is able to push to production in just a few days, and also to make wide refactoring in a few weeks. The trust and the confidence we have in the code is part of the success. Let's see what we learned so far about ReasonML. ReasonML is, as a language, is as mature as OCaml. OCaml is about 25 years old. Generally, when we aim for safety, we want a type language that is sound, so we know that the types are not lying. In that respect, ReasonML is safe. It has a static type system with soundness guarantee, giving you 100% static type coverage. What else? ReasonML is immutable and functional by default, but it's also pragmatic. It encourages pure functional code, but allows imperative code when needed. So sure, we have the benefits of sound typing and functional paradigms, and they are all great, but is it really worth the overhead of learning a new language? So in the case of ReasonML, and its familiar syntax for those who are migrating from JavaScript, the overhead is minimal. The language is also ergonomic in terms of readability. Types are inferred. So the code is not verbose. The compiler catches your errors and show you exactly where to fix it, so the feedback loop is getting shorter. You have also fast and performant compilation into efficient, relatively readable JavaScript code. And last thing, in case you need it, you can write once and run anywhere, not only on the web. Amazing. So I hope you're ready to explore more on your own. Here are a few links that might be useful. You can play with ReasonML in the browser, consult with others on Discord, edit to an existing JavaScript project, or start from scratch. You are more than welcome to contact me. It is Sara Hillel on most platforms. That's it. Thank you very, very much for joining me. Thanks to the team of this great conference. And thanks to my coalition of women and men for supporting, providing feedback, and making this talk happen. Thank you. Ciao. Bye-bye.